Hey guys, it's Wednesday, May 13th. Today we're going to take chapter 10.2 notes. Make sure you've got those in front of you or something to write with and a piece of paper to take notes with. Pause the video right here and try this warm up. Determine whether the fraction is in lowest terms. Can you simplify it? If you can't, you write it's in simplest form. If you can, go ahead and simplify it. Alright, let's talk about number 1. Now it says determine whether the fraction is in lowest terms. Now as I'm looking at these, I notice that 6 and 14th are both even. So I know it's not in simplest terms. I have to reduce it because they're both even. At least 2 goes into both of these. So if I do that, divide top and bottom by 2, I'll get 3/7. Let's try number 2. Now as I'm looking at this, one of them's even and one of them's odd, so I know that I can't divide by 2, but could I divide by 3? 3 goes into 12 evenly. 3 also goes into 27 evenly, so it's not in simplest terms. So I'm going to reduce it. Let's look at number 3. Number 3 is 7/10. Now 7 is a prime number, so nothing goes into 7 except for 7 and 1. It's in simplest terms, 7/10. What about number 4? One's even and one's odd, so 2 won't work. What about 3? I noticed that 7 goes into the bottom. I think that's the best we can do. It's in simplest terms already, so we'll leave it just the way it is. What about number 5? Are there any numbers that go into both the top and the bottom? As I'm looking at my multi-chart that goes up through 20, there aren't any numbers that go into 16 and 25, so that's in simplest terms. Let's look at the last one, number 6. Both of these are double digits, 22 and 44. So on my times tables, I know that 11 is going to go into both of these at least. So if I divide by 11 over 11, I'll get 2/4. And that could even go again, 1/2. All right, here's our essential question. How can you describe the likelihood of an event? Feel free to pause, write that in the essential question box. Here's the key idea from the notes. We're going to start talking about probability. The probability of an event is a number that measures the likelihood that the event will occur. Probabilities are between 0 and 1, or never gonna happen, 0%, and 1, certain, 100% chance, including 0 and 1. So that all of the probabilities are in between 0 and 1. This diagram right here relates likelihoods to probabilities. This chart right here is super important. Every probability lives between 0 and 1, where 0 is impossible, not going to happen, where 1 or 100% certain likelihood means that it will happen, certainty. Now, honestly, of all the things that could occur in our natural world, none of them are 100% or 0%. They all live in this area, this middle part between 0 and 1. So we've divided it into quarters, where a quarter or 25% chance means it's unlikely to occur. Halfway is a 50-50 chance. It's equally likely to happen or not happen. And a 75% chance or 3/4 chance is likely to occur. Let's try some examples. There's an 80% chance of thunderstorms tomorrow. Describe the likelihood of the event. So tomorrow is an 80% chance of thunderstorms. Where does it lie on this diagram? And it's probably like right here or so. So we'll say that the likelihood is likely. It probably will occur. Now, the likelihood that it'll be sunny here tomorrow is probably 90%. So it's likely that it's going to be nice and bright and sunny tomorrow here in Southern California. So when we find the probability of an event, the probability, remember, is a number. It's a fraction, and it lives between 0 and 1. To find it, we need to make a fraction. The probability of an event is the number of favorable outcomes, you get what you want, over the number of possible outcomes, or the total outcomes possible. Let's try an example. You roll a number cube, which has 6 sides. What is the probability of rolling an odd number? Let's start by writing the formula from before. The probability of rolling an odd number is going to be a fraction. The number of odds, because we want odds, the number of odds over the total number of outcomes. Total outcomes. So the probability of rolling an odd, how many sides are on this cube? How many outcomes are there? Well, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So there's 6 outcomes. How many of those outcomes are odd? I'm going to make a list right here. 1, 2, 3, 4, 5, 6. 1 is odd, 3 is odd, 5 is odd. 3 of the outcomes are odd. So the probability is 3/6. But you can reduce that. You can reduce that to 1/2. Let's try another one. Let's try a different one where we're still going to use the number cube. But this time, let's talk about the probability of getting a number greater than 2. So, new question. Probability of rolling a number greater than 2. And this is going to be a fraction of the number of outcomes greater than 2 over total outcomes. One, 2, 3, 4, 5, and 6 are our total outcomes. This is a list of all the outcomes. How many outcomes are there? There are 6. How many of them are greater than 2? 3, 4, 5, and 6. So there are 4 of them greater than 2. So the probability of rolling a number greater than 2 is 4 out of 6. You can reduce that to 2/3. Now, would you say that the probability is likely to occur, unlikely, impossible? This is like a 67% chance, so it's likely to occur. Let's try some more. Let's look at number 2 down here. It says there's a 100% chance that the temperature will be less than 120 degrees tomorrow. This likelihood is known as certain. It will happen. Right? The chances of us reaching 120 degrees tomorrow is none. Make sure to summarize your notes. Come to office hours if you need help. They're tomorrow. Make sure you got probability and likelihood and how to describe it in your summary. Give the homework a shot, and I will see you soon. Bye.